All right, welcome to Scaling Mobile with YUI. My name is Jeff Burtoft. I'm a developer. I'm the lead front-end developer for a company called USAA, located in San Antonio, Texas. And I have been a front-end developer for a number of years now. Probably about 16 years I've been working the front end. My first job was as webmaster of my university. Anyone else ever carry that title? Pretty cool times, cool titles if nothing else. It was back when only kids were allowed to work on websites because real programmers were busy doing things that were much more important. But it was a good opportunity to get in the door and really build a love for development and working with the client. I live in San Antonio, Texas. Do we happen to have any other Texans here with us today? All right, good to see you guys. So I'm assuming the rest of you guys are from California. Safe assumption? Well, we have a name for California in Texas. We call it far, far West Texas. And we actually have a name for Californians as well. We call them pre-Texans. They're people who haven't yet moved to Texas yet. Okay. So public speaking 101, start out by insulting your audience and you've got them for the rest of the time. All right, well, we're really talking about mobile today. USAA, we're a company, we may be the biggest company you've never heard of. We're a Fortune 500 company. We're number 145 on the Fortune 500 list. We sell banking products, insurance products, and investment products to military members, veterans, and their families. Now, there's something unique about USAA for a company our size. We're privately owned, which means that we don't have shareholders that we report to. Instead, we have customers, and we call them members. So those are the people that we're reporting to. Do we happen to have any USAA members in the room? Wow, it's always a pleasure to present to USAA members. Thank you very much. So USAA, because of the nature of our customers tend to get deployed around a lot and move around a lot. And they will, a lot of times, only have their phones or maybe even their tablets with them to connect to the internet. So mobile is very important to us. It's a key strategy for us to be able to connect our membership to the services they provide. We're very particular about the quality of our applications and the quality of the work we do. This is a few of the accolades that USAA has as a company. For the last 2 years, we were voted the #1 place to work for in IT. And I can tell you it's a very great place to work for. It's in the great state of Texas, and it's fun because you really have a lot of diversity in what you're working on, and you have a really great mission of serving the people who are in the military. So we're going to talk today about mobile applications from a corporate perspective and what it takes to make some really good applications. We're going to start out by looking at what Fortune 500 companies want from mobile. What is it that they're looking for? So is it web? Is it native? What's the best delivery for a company to go into as a strategy for mobile? So first of all, looking at the native side of things, if you're going to build a native application, there's certain benefits that you get from building that native application. First of all, the experience of a native application is very hard to match. You get instant access to data, smooth transitions, loading an application within seconds. There's a lot of very pleasing and pleasant experiences that you can get with a native application that's very difficult to recreate with web. Second of all, you get access to the hardware. iPods, iPads, iPhones, Android devices have accelerometers and compasses and cameras and hardware that's very key to access to be able to get a lot of the different features to work together in your application. When you're writing a native application, you have access to everything that's in that hardware layer. That's not so in the web. The app stores is another big one. So being able to put your application into one of the app stores and have your members go there to find it is important for a company. Today, the average person will go to look for an application not to Google or to Yahoo or to Bing to search for it, but they're going to go into the App Store to download it. They want to know, is there an app for that? So as a company, having your app in the App Store is a big benefit for a native application. SDKs are also very important. So the software development kits give a standard set of visual components that the developer can utilize within their application. And what that does is it gives a consistent experience across the different applications. You can have application A built by one company that has buttons that look exactly like it does in the OS and exactly like it does with another application built by a different company. So consistency of experiences provided by the SDK. And then of course brand recognition. Everyone wants to say that we've got an app in the App Store. Every company wants to put on their marketing materials that you need to go download our app. That's a big feature of a native application. So from the web side, you wonder, well, what's left as far as the benefits go? There's quite a few. So easy delivery is one of the big selling features. When you have a web application, it's easy for a person to just go to your URL, load the application, and it downloads immediately to their device. They don't have to go through the App Store. They don't have to go through a big process to get access to your application. No potential paywalls. So whenever you build a native application and deliver it through one of those marketplaces, there is going to be a company who controls that environment. And today they may have made decisions that make it easy for you to do business within that controlled environment. Tomorrow they may not make it as easy for you to do your business. The web doesn't have those limitations. So you know that you're going to have the freedom in the future to do what you need to do with your application and for your business that you don't necessarily have within the native environments. Easy maintenance. Has anyone ever built a bug into an application? You don't have to answer that. The answer is obviously yes. If you deliver it through a native application that goes into an app store and has to be downloaded by a user, if you find that bug, you then have to submit a new version of your application to the App Store and hope that your users go and download it. It may take days, weeks, or even months for a user to go and download those applications. So every once in a while, I'll grab my wife's iPhone and I'll go into her App Store and she has about 45, 50 different applications that she's never downloaded, and I spend the next hour updating all of them for her. But there's a lot of people out there like that. So you can't be guaranteed that when you submit a bug fix that it's going to get to your users. Well, on the web, the delivery mechanism is much more controllable for you as a developer. So if you have a bug fix, if you have a defect that you need to address, you can submit it into your code base. The next time the user comes to load your code from your website, they'll get the new version of the application. Higher reusability. When you write a native application, it's generally distributed for that device and not reusable to another device that's made by a different company. When you write with the web, just like we had with desktop computers, we have with mobile devices as well. You're able to write once, use it everywhere. And then lastly, it's public. There's often an uncomfortable nature for a user to go to a company that they don't already do business with and download their application and install it on their device. It takes a level of commitment by that user to do that. Well, the websites are different. Customers feel comfortable going to a website and visit it, even though they don't currently do business with the company. So having the public access to your application is important on the web. So what is it that companies do want? Well, obviously, we want both. We want the best of both worlds. We want everything. And those are all good features to desire. So what we've seen on the rise is we've seen the hybrid application develop. So a lot of companies today will take the best of the web and the best of native and put them together. So hybrid application usually starts with a native base, and it's the native code that might give you access to certain APIs or handle some advanced animations or even certain larger sections of your application. And then it gives you web views into your web application. So a web view is basically a window. It can cover the whole application or it can cover just a section of the application in which you make a request to web technologies. That may mean a web page that's stored within the application, or it may mean a web page that is pulled from your website. So the web views allow you to have that flexibility to update applications, ones that may change quite a bit without the user having to download a new application. And the native application gives you the ability to submit it into the App Store, distribute it through the different environments, and kind of gives you the best of both worlds. So some of the trends that we've seen lately in hybrid applications is the web is able to perform a lot more of what we used to have to do with native. And I gotta be honest, Apple is one of the biggest contributors to this change because they're giving us more and more access to APIs and hardware functionality within the web views that we didn't have a few generations ago. So you're seeing more functionality being done in the web, which leaves less that has to be done within the native application itself. So we're going to be looking at how to maximize that functionality. How do you maximize the web? So we're going to look at 4 keys to maintaining quality whenever you're scaling with web on mobile. So as you write more and more applications, it's important that you have some ways to maintain that quality. For a company like us, we write a lot of applications. We have hundreds of developers, and people count on our applications functioning consistently. So the first thing we're going to look at is reusability. It's key to be able to write something once and use it over and over again. You don't want to have to take a functionality that you've written once and rewrite it just to use it in another portion of the application or another application itself. Compatibility. You not only want your application to work for everyone, but you want it to work well for everyone. Flexibility. Know that within your environment, there isn't going to be one size that fits all developers. Sometimes you need a lot of structure and a lot of rules, and other times you don't. And then last but not least is performance. We're going to look at managing memory, loading quickly, and making sure that your application works elegantly on the devices that you're intending to support. Okay, reusability. When you build hundreds of applications, you don't want to start from scratch every time. So what I have here is a little chart that we use that talks about some of the different technologies that we put together at USAA and Stack to build our web applications. And the basis of those is based off of a framework called Wicket. It's a client-side framework. Do we have any Wicket users out there? Anyone with experience with Wicket? All right, so Wicket is not always the first framework you would think of when you think about combining a client-side framework with YUI. But what it does bring to the table is it brings a really great structure for componentization. So you can take a piece of code and write it as a component where it doesn't have any other ties or any other dependencies to other components on the page, and put those components together to build a page and deliver it to your members. Well, likewise, YUI gives you that same extensibility. You can take a component and build it so that it doesn't have any other dependencies and move it from page to page, from application to application. So we take these different technologies and we stack them on top of each other, and we build components, throw them in our own library, and have all of our other developers access to them. So this is kind of how we break it down when we're using components. There's different levels of skills and different amounts of time it takes to build or use a component at USAA. So the heaviest here on the right is to build a component. It takes the most time, it takes the most varied skill set to build that initial component. So you may require the Java skills to build the Wicket application portion, HTML5, YUI, CSS3, and that often doesn't lie within just one developer. It often means a team of developers working together to build this initial component. It takes a lot of time, takes a lot of energy, but once it's complete, it's put into a library for reuse. And it falls then under one of the other 2 categories, where you can either take a component and extend it, or take a component and reuse it exactly like it is. Extending a component doesn't take near as much time and near as much of a varied skill set as it does to build that initial component. So it takes fewer developers to extend a component. You may have a component in your library that almost meets the needs that you have. Instead of starting from scratch again, you can take that component extend it, add the features that you need to it, reuse it yourself, and then put it back in the library as an extended component. Other times, all you need to do is pull that component out of the library exactly like it is and use it on a different page or in a different application. And that doesn't require a lot of skill set at all. It usually just requires someone who's a Java developer to take that component and extend it into their own application. So componentization gives us a structure to our teams where where we can save time with different groups by allowing them to use something that already exists. So I want to focus a little bit on the YUI layer of this and look at a case study here of use of widget, of the YUI widget. So what we have here are screenshots from one of our personal financial management applications. This application was delivered as a web view inside of both Android devices and iPhone devices. And each of these components here, these visual components, were all built off of the YUI widget. So some of them are pie charts, some of them are bar charts, some of them are list, legends. Varied, they have a varied functionality to them, but they all come from the same base. So this is how we started out. We took the YUI widget and we extended it. And we made our own USAA base widget for this application. Inside of that extended widget, we were able to stick our standard list generator, a basic template, and our touch and click events so that this component would know when it should use touch, when it should use click. And we added the ability to have a scroll view within each of the components and a few other base functionality that we knew we would need in most of the visual components on the page. We then took that application and we extended it. We added a model to it, created a new template. In that new template, we had the CSS classes that brought in the right look and feel and updated the structure to present the data that we needed. We were then able to take that same USAA base component and extend it again. The first time we created a list element that listed out the different transactions from an account. We were then able to extend that same base component again and be able to build a pie chart from it, extend it again and be able to build a bar chart from it. We then found out that some of the other components we had more in common with an already extended component than it did with just the base component. So we were able to take some of those extensions and extend them again. So a pie chart could then become a legend by updating the template a little bit and removing the scroll view. And then we found out that as we were building all of these different components, we found other functionality that were in common from each of those other extended components. So we were able to take that functionality and move it back into our base extended object so that all of the different components would have access to that functionality. So what we were able to do is we were able to take a single object that was extended from widget and extend it again and again and inherit functionality that was common across all of our components. We built our pie charts, our bar charts, our transaction rows, tables, everything from that one component. And not only did it save time in developing the component because that code didn't need to be written over and over again, but it also saved page weight because we didn't have to reproduce code. We didn't have to write the same thing and deliver it twice because it was in two different applications. Additionally, it gave us some very strong patterns to the way that we wrote these applications. So each of these components were based off the same widget. Attributes could all be accessed the same way. They all had getters and setters. And it was a very common interface for a developer to work on a component that another developer had written and be able to jump in and know exactly how that component was going to work. So it made it for a very reusable environment within the application. So moving on to compatibility. Compatibility is essential within mobile applications. And I have a bit of a pet peeve when people write applications that only work on one device. If you're writing code that is only intended to work on the iPhone, then you should probably just write native code because that's what it's for. It's for writing something that works specifically in that environment. The web has a lot of flexibility to it, and it should work across browsers. A lot of times, from a business perspective, they look at the mobile frontier and they think there's 2 devices that they need to support. This is probably a good time to poll the audience here a little bit. I used to ask how many Apple fanboys I had in the audience, but it turns out that's apparently a derogatory term to fanboys. And if you find that a derogatory term, you're probably a fanboy. Works out that way. But who carries an iOS device in their pocket today? Okay, and who carries an Android device? Okay, well, we're pretty heavy weighted to iOS. So Android people are usually offended when I talk about this next section. So the iPhone. Supporting the iPhone is not just supporting one device. First of all, you need to be clear on which devices you're going to support. Since Apple brought out the iPhone, they've had the 5 different generations of it, from the original iPhone through the 3G, 3GS, 4, and the 4S. And if you're working with a web view that's inside of your native application, that native iPhone application can be downloaded onto an iPad and used on an iPad or an iPad 2 as well. So those become different environments that all have their own special rendering that they do for the web views. So you have to be aware that all of these devices are on the market and being used today. Especially if you're supporting international users. We see a lot of original iPhones and 3Gs being used in the international markets. So if you're going to support iPhone, you need to support all these devices. And don't forget about the different OS versions. As hard as it is to get someone to upgrade your application, it's often harder to get them to upgrade their operating system. So within these different devices, you also have a myriad of different OS versions out there. So for Android, it's not as easy. We have a variety of manufacturers, which is a good thing. We have a lot of variety in devices, and those manufacturers will ship sometimes the same phone to different carriers under different names that behave just a little bit different. In any given year, you can have a new phone released with one of 5 different OS versions of Android running on it. So it's very difficult to say that you're going to support Android devices without knowing what environment it is that you're going to test it on. So I'm going to look at a case study here on Scroll View. The same application that we built and showed you the screenshots for before, the personal financial management application. We ran into a little glitch whenever we were using Scroll View. So this is the YUI Scroll View component. We had it built into each of our components. And whenever we were testing on the browsers on the phones themselves, we didn't run into any problems. As soon as we brought our application into the web views of the native applications, we ran into problems on 3 of our phones. So 3 of our most popular phones had difficulty using the Scroll View. It was pretty easy to diagnose. We had plenty of view, but no scroll. So you would touch the screen and nothing would happen. So I was working with a team. I was leading a team of developers for this, and being the front-end developer that I am, I consider one of my key skill sets to be troubleshooting. So I told the team to step aside and allow me to take this on because I knew how to fix bugs. So I went through the process, and I pulled the code apart, tried to understand everything I could about Scroll View, looked at the different events that were being utilized at different times, thought about all the other events that may be taking the touch controls away from the Scroll View before it could be used by the JavaScript component itself, and tried to prevent any events that I could, and I couldn't get anywhere. I just assumed that Scroll View itself was broken, that it wasn't written very well by the YUI team or something of that sort. And so I went out to some of the other scrolling JavaScript libraries out there. We pulled in iScroll first. I don't know if any of you guys have used that before. Loaded iScroll in instead, and it didn't work either. Couldn't get it to scroll on that. I decided I would take a look at Sencha, see how Sencha solved the issue. They worked on a lot of web views. And I loaded a Sencha application inside of my view and couldn't get the Sencha to scroll. We then tried an application that we had written ourselves to handle scroll, threw that in there, and I couldn't get any of these scroll views to work. So I moved on to step 3, which was to cry and get a couple gray hairs. At least I didn't have to go as far as Dave did and lose part of it. I went home, complained to my wife, but unfortunately she's neither a developer or a YUI contributor, so she had no help for me there. And then finally I moved on to step 4, which was to provide an alternative experience for some of these devices. So devices that supported the scroll view and it worked, got the application. The other devices were moved to an experience that provided them this functionality without needing the scroll view. So it is important to know that you can't fix everything. Not every phone is going to support every version of JavaScript, and it's not going to support every feature that it is that you want to use. In fact, you don't always want to fix every feature. Sometimes fixing a feature for all phones means not being able to use some of the newer technologies for some of the phones that can adopt it. It may mean making the environment worse or heavier for devices that don't need that fix in there. So what was the problem exactly? I mean, aren't all Android phones created equal? So let me walk through the process a little bit of what happens with an Android device. So Google produces the operating system, and they put all the fit and finishes on it and then release it to the manufacturers. It's then plain and has potentially all the functionality working in it. It's then sent over to the manufacturer, and the manufacturer will put their layer on top of it. So all the manufacturers want ways to differentiate their device from the other devices. So they may add additional functionality, update the UI, and do things to it that will make it stand out in the marketplace. Well, then they pass it over to the carrier, and the carriers themselves will often put code on top of that. And it may push you towards specific services that they have contracts with on that carrier, or it may add some additional functionality that will draw you towards that carrier. So a single device that has an operating system that's produced by Google, manufactured by a manufacturer, and then sent to different carriers will have different functionality. So what we found with this particular issue is that the 3 devices that didn't work were all from the same manufacturer. So we assumed that there was something about the manufacturer install that we were missing, so we tried every device we could from that manufacturer and still found out that really only those 3 devices had this problem. We then realized that those devices were also all produced by the same carrier. They were all released on the same carrier. So same operating system from the same manufacturer on the same carrier all had the same problem. So luckily we had a little bit of a relationship with that carrier, so we worked with some of their developers and realized that there was a bug within the layer that they had put on top of the device that was stopping the touch events from falling down into the DOM layer. Once the initial touch event was captured by the screen, it was never passed down to the DOM itself. So at that point in the web view, only click events were getting through. They had also updated it in newer versions of their phones. So we were happy to know that the choice to provide the alternative experience for those users really was the best choice. There was nothing that we could have done in our code to get that working. The best thing we could do is provide a different experience for those users. So taking compatibility one step further to adaptability. So YUI is definitely the benchmark for this. They do really great at packaging code based on the functionality of that device. The more you know about the device that you're using and what it supports, the more you can send down a code base that is built especially for that device. So if you have a larger screen size, you want to take advantage of that screen size. If you have a phone size screen size, you might want to build your component a little bit different. And if you know what your device is up front, you can lay out the screen differently. So additionally, it allows you to adapt to the environment. If you can take advantage of CSS3 transforms, it's important that you would do that. If you use the 3D transforms that will take advantage of the GPU of the device, you should do that. But not all devices will support CSS3. So if you know from your client's perspective that it does or doesn't support CSS3, you can appropriately send down code that will help that code base adapt to that device. Use the GPU if it can, fall back to JavaScript animation if it doesn't. We use YUI heavily here to fill in the holes. So some of the devices with earlier operating system versions that don't support some of the features we want to use for our users, YUI will often provide that code that fills the gap and allows us to provide that functionality a different way for those users. So whenever you have an environment that will adapt to the user, it's going to bring you as close to a write once environment as you can get, where a user can go and visit one site and you'll cater the code to them. Instead of sending desktop users over to this site, mobile users to this site, and tablet users to this site, it allows you to send them all to the same place and let the code determine what it is that it wants to provide for them. All right, moving on to flexibility. So not all developers are created equal. This is my example of that. You probably know the guy on the left. He's the one who discovered that JavaScript has good parts. This guy on the right, that's me. He's the one who built all the bad parts into the same application. So just because you have a good developer doesn't mean that he's going to be a good JavaScripter. A lot of times the best developers that I work with who are Java developers know to call a JavaScript developer when they need something done in JavaScript. So again, to quote Douglas Crockford, many people write JavaScript if you know how. And we really are big fans of Douglas Crockford at USAA. I pass out little bracelets to all my developers that say WWDCD, what would Douglas Crockford do? And I make them wear it. It's great. That's not entirely true. I don't make them wear it. They really just want to wear it. So we're going to go back to this chart here. When you have developers with varied skilled sets, and we looked at what it takes to build a component, extend a component, and use a component, USAA is primarily a Java shop. The majority of our developers are Java developers. We have maybe 30 to 50 front-end developers right now who are working on this. So when we're building a component, it's important that we get all of the developers who have the right skill sets to work on that component and put that component together. For the initial development, when you extend that component, you generally don't need as many skill sets. You can do without some of your YUI experts if you don't need to extend the YUI layer of that component. Additionally, if you're just picking that component up off the shelf and using it as it is, you really just need the Java developer skill set. So it's important whenever you're scaling, when you're writing a lot of applications, that you have the flexibility. It's not a good idea to assume that all of your developers are going to have strong skill sets in all the different technologies that you want to use. If you do that, one of two things is going to happen. Either you're going to limit the number of technologies that you can use, because if you're only going to use technologies that all of your developers are familiar with, it's not going to be many, or you'll be disappointed and you'll get some poorly written code from developers that you might expect more from. So it's important to have a flexible environment. So you say we kind of have three different flavors of JavaScript that we use on different pages, and it really depends on who's writing those pages and what that page is going to be used for. First of all, the full YUI version, we use YUI 3 on all of our mobile applications. If we're writing anything with a client-side MVC, anything that has advanced functionality or that takes a data object input, it will use the full YUI. If we have a page that might just have a little bit of functionality, and especially marketing pages that may only be around for a few days or a few months, don't require the specialized skill set, we'll pull out simple YUI for those pages. It doesn't require all the complexity of YUI itself, so it opens up to the number of developers who can write it. And then some pages, we just have very simple pages that have simple JavaScript needs, sometimes don't have any JavaScript needs at all. So if we just need to validate a form or have a very small portion of the application that would require any behaviors, we'll just use JavaScript for those pages. So we have the flexible environment that allows us to use complexity when we really need it, build structure into the application when we really need it, and then go without it when we don't. So last but not least is performance. So performance is very important when you're using mobile devices. You know, I haven't mentioned this a lot in the talk, but one of the keys to maintaining quality is testing and testing often. It's difficult, I know, to get your hands on a lot of devices. Some of the guys from my shop make fun of me because I basically will have, you know, 5 or 10 different devices on me at any time, from tablets to phones, because I like to see how applications are going to work in all of the different devices. There's companies out there like Perfecto Mobile that will provide you access to a lot of the different phones and tablets out there on the market so that you can test your application on them. But it is important that you test on an application itself. Don't assume just because it works in a browser that it's going to work inside of the browser on a phone, and even more so inside of a web view. So we're going to look at 3 things here. Memory management. Devices have resource constraints. So we all know that we have a limited amount of RAM within the devices. The processor is limited. The amount of power that you have access to, or the amount of power you want your application to utilize, is important to be aware of. Loading quickly. Making sure that you're loading small packages. If you have a lot of functionality on your page and you have a lot of JavaScript to run it, it's going to take a lot of time to load it. No matter what techniques you put into place, a lot of code generally takes time to download. Building into a single request and reducing the dependencies certainly does help that. And then also you want to make sure that it works elegantly. Sometimes you can have code that works on an iPhone 4 or an iPhone 4S, but it works very poorly on an iPhone 3G or 3GS. So it's important that if you're going to support those older phones, that your application will work well on it. So a little bit of data for managing memory. These numbers here, the iPhone itself will allow you 10 megabytes of memory per window. So if you open up a browser window, you can have up to 10 megabytes worth of memory within that window before it starts to do some pretty wicked memory management and deleting things from your memory for you. That's not a whole lot to work with. It may sound like a lot, but when you start to add up the footprint of your JavaScript and DOM, and the amount of images that you have in there, it starts to be eaten up pretty quickly. It gets even worse when you move inside of a web view. Web views have even more constraints on the amount of memory and the functionality that you have available in those web views. So from experiential data, an iPhone web view has less than that. They have about 6 megabytes before you start to run into memory problems. Now, if you are on an iPhone and working inside of a web view, once you start hitting that ceiling of memory, usually the application will crash. I've seen applications crash just because the images inside of them were built for a Retina display and were too large for the web view itself. Some of the Android phones are a lot better, especially the newer ones on the market. The Nexus S has 20 megabytes of memory per window available to it. And you got to keep in mind that this is all pending the available system memory. So if your iPhone has a lot of applications running in the background, then the amount of memory that you're going to have left for that window that's on top may be smaller than it needs to be. Moving on to loading quickly. Your JavaScript frameworks can be quite heavy. And this is a challenge I put out there for anyone who works with a JavaScript framework, especially obviously YUI. Do whatever you can to make that file size smaller. YUI, please continue to componentize and work towards that effort to make those requests smaller, because that's very important within the mobile device. Whenever you load these different frameworks, and I kind of have the sizes there, YUI itself at 21K, Simple YUI at 36, Backbone at around 7K, and Sencha at 120K. That's just to get your functionality starting. Now, whenever you start pulling in other modules and other functionality, and then your own JavaScript code, that time goes up. So whenever you're loading an application, you want to consider both the load time and the time it takes to render that JavaScript as well. If you're loading your JavaScript in 5 seconds, but then it takes another 3 seconds to render all the JavaScript that you've loaded, to a user, that's an 8-second wait time. So make sure that you consider that initial render time it's going to take within your load time. So just to give you kind of a frame of reference, our standard for a mobile application page wait is 20K. So we really don't have any applications that have been able to meet that standard yet, but that's our goal. We want to see each of our pages get down below 20K. So a question that's often asked to me is about app cache, because I've heard many times people say, well, with HTML5 app cache, it really mitigates the need for the small files and to be concerned about the file download sizes. So this chart up here kind of demonstrates what it's like using app cache within a dynamic environment. So if you have a page that's dynamic, and that page could have different markup that's delivered for a different user, it may mean that you have your initial JSON object on the page, and that'll be different per user, or it may have date timestamps or something that change. Anything that's going to change about that initial page, if you're using HTML5 app cache and you have your manifest file on your initial page, that initial page will automatically be cached with all of your other assets. So you can't place it on a dynamic page. So one way around that is to insert a jump page. So your application would hit a jump page first, which may be just a loading screen, but an opportunity for you to go and request all of the assets for your application, load them on that jump page. That jump page will then be cached along with all the other assets, and then you can forward yourself on to your dynamic application, which will then be able to pull all of its assets from the app cache. So there is a workaround for it. It's a little bit difficult, but there's other things that you have to consider when you're using app cache. Obviously, we looked at why you can't load it from a dynamic page, but it's also problematic with server-side states where the URL doesn't change. So if you have ever seen an environment where you will reload the URL and the URL will be the same, but the data on the page will change. Maybe you're going through an application and it always uses the same URL with a postback that then loads the second page of the application. Well, that doesn't work with app cache because it looks at the URL that's being requested and ties it to the data within its app cache. So you can't use it to store resources of a page that is dynamically generated but has the same URL, or you may be caching the wrong page. It's also difficult to manage the manifest file. So in our environment, we do releases, and the releases are all automated. They know when to update the expires headers for all of the assets, and they will know when to tell a user to download new assets. So obviously you want your manifest file to change at the same time. So it's difficult to systematically know when you're going to change or update your JavaScript files and make sure that you're going to reload the right manifest file so that the user doesn't get a mix of new JavaScript and old JavaScript. The last thing is web views. If you're using app cache within a web view will have sometimes surprising behavior in the way that it will cache your data. The cache life may be based on factors that are outside of your control. So a user may have a limited system resources, they may have installed and reinstalled your application. There's a number of different things that can trigger that cache to be deleted that you don't have control over. So moving on to working elegantly. So again, if you support the different devices, you want to make sure that your device works well within that application. If you have a Android phone or a iPhone, the amount of memory that is available for your application will be dependent on the number of applications that are running within that operating system. So if you're doing all your testing on an iPhone that only has your app on it and isn't running anything in the background, you're probably not simulating true user data. So you want to make sure that you take those things into consideration to know how your application is going to perform on a real user's phone. You want to make sure that you take advantage of HTML5 features when you can. So if you can utilize the hardware acceleration, you want to do that. So use 3D transforms whenever you can. Quick render time. So again, whenever you load JavaScript, take into consideration as well the amount of time it's going to take your user to render that JavaScript. Make sure that you're loading your loading treatments at the appropriate time as well. If the first thing you do is render your JavaScript and then you render a loading treatment, your user may be looking at a blank screen for quite a while. You want to make sure that you very first thing that you do is load your rendering or your loading treatment. A lot of the time I like to recommend to our developers to build their initial interface with markup so that the user has something that they're looking on, something usable on the page while they're loading that JavaScript in the background. And of course, it must manage memory and resources. Know the limitations of the devices that you're using. Battery life's important. You don't want something that always has the GPS on that's going to be draining the battery of the user. Screen size will vary from device to device. And you want to make sure that you're not loading data that you're not going to use. Most users in the US, and just about all users outside of the US, pay for their data. And if you're loading data that you're not going to use in your application, or if you're doing too much preloading, you may be you might be disadvantaging your user because they're loading a lot more data and paying for a lot more data than they're going to need. So wrapping up here, so making web work for mobile, reusability, again, is real key. You want to make sure that you're not starting from scratch every time that you write an application. When you write an application, think about the number of ways that you might be able to reuse that component in the application that you're writing or within other applications. Compatibility, make sure that your device works well across all the devices that you say you're going to support. It's difficult when you look at a user agent string to tell the difference between an iPhone and an iPhone 3GS and an iPhone 4. So you want to make sure that you're appropriately providing experiences for the different users. Flexibility, not all developers are created equally, so you want to make sure that you have an environment that utilizes the skill sets of the developers that you have available. And then performance is always key within mobile. Whenever you're developing for mobile applications, make sure that you're not writing an application that works well on the desktop or even works well in the browser but doesn't work well in the web view. Make sure you test it within the environments that you're going to use it in. A few of the credits for the images and logos that we utilized here. And then this is how you find me. I'm not much on social networks. I think I only joined Twitter to find out what Justin Bieber had for lunch one day or something, and I've had that account ever since. But you won't get much from me, but please follow me if you're interested. I do more retweeting than anything. Okay, well, we are out of time. If you have any other questions, I'll hang around up here, but thank you all for coming to the presentation today.